Section 12.3, Inscribed Angles. An inscribed angle is an angle whose vertex is on the circle and whose sides contain chords of the circle. An intercepted arc consists of the endpoints that lie on the sides of an inscribed angle and all the points of the circle between them. Remember, circle is 360 degrees when solving for arcs. An arc can be named with either 2 or 3 points. So in this case, DEF is the inscribed angle. Notice that the vertex is on the circle itself, and you have your chords. DF is your intercepted arc. So here it introduces us to the inscribed angle theorem. The measure of an inscribed angle is half the measure of its intercepted arc. So the measure of angle ABC is 1/2 the measure of the arc. Find the measure of each. So here they ask for the measure of PRU. Well, PRU is this angle here. And so to find that, we have to do a couple of things. The first thing we need to do is actually find the measure of SP, or arc SP. Well, I know that arc SP should be double the angle that it cuts, or that's cut by it. So if the angle here is 27, this arc should be 54. And then to find PRU, well, actually, we didn't need arc SP for that. PRU is actually cutting arc PU, so that means we need half of the arc to get the angle. So we know that this is going to equal 1/2 the arc it cuts, so 1/2 of 118. It's going to give us an arc measure of 59. So PRU is 59 and arc SP is 54. And the next example says find the measure of each. So we're looking for the measure of A. Well, for A, the angle that cuts A is this angle here that has a measure of 60. So the arc should be double the angle that cuts it, so therefore the arc should be 120. And then the other one, we're looking for angle B, which is made by this measurement here. Well, this piece of the arc is 30. We know that A is 120, so together it's 150. So we know that this is equal to half of the arc it cuts, which in this case would be 150. So B equals 75 degrees. Here we're looking for the measure of all 4 angles, ABCD. Well, for A, we know it cuts the arc from here to here, which is 190. The inscribed angle is half of the arc it cuts. So we've got half of 190, which in this case is 95. And then angle B cuts from here to here, which means it's half of the arc it cuts, which is 154. So 1/2 of 154 gives us a measurement of 77 degrees. So angle B is 77. Then we move on to angle C. Cuts from here to here. So this arc here should be 170. So angle C is half of 170, which in this case should be 85 degrees. And then it's very similar, we do the same thing to find the measure of angle D. In this case, we're going to take half of 206, and we get angle D is 103 degrees. Corollary 1. 2 inscribed angles that intercept the same arc are congruent. Corollary 2. An angle inscribed in a semicircle is a right angle. So basically, if the arc is 180, you know that the inscribed angle has to be half that, so it has to be 90, so it'd have to be a right angle. And then corollary 3, the opposite angles of a quadrilateral inscribed in a circle are supplementary. So angle D and angle B should add up to be 180, and angle A and angle C should add up to be 180. Here it asks us to find each measure, so we're looking for the measure of angle 1. Well, angle 1 cuts the circle at this point, which is your diameter, so it cuts half the arc of the entire circle. So the measure of angle 1 should be half of 180, which in this case is just 90. Here we're looking for angle 2. Well, angle 2 cuts this arc here, but so does this angle here, which is 38, and since they cut the exact same arc, they must be equal. So the measure of angle 2 is just going to be 38 degrees. Here we're looking for the measures of angles 1, 2, and 3, and 4. So just like we did previously, looking at angle 1, I know angle 1 cuts at the diameter here, which means it's cutting at a semicircle. So half of 180 gives me a measure of 90. So if this is 80 here, this has to be 100 to make a semicircle. If this is 60, this has to be 120 to make the other half of the 360 piece. So if I'm looking at angle 2, it's cutting from here to here, which means angle 2 should be half of 220 degrees, which in this case would be 110. Angle 3 also cuts at the diameter, so it cuts at a semicircle. So angle 3 should also be 90 degrees, because half of 180 would be 90. And then last but not least, we've got angle 4. And angle 4 cuts from here to here, so it's going to be half of 140. So angle 4 is just 70 degrees. Here it's asking us to find the measure of angle EDF. Well, if we look carefully here, EDF cuts this arc here, as does EGF. So what we notice about those two angles is that they have to be congruent since they're cutting the same arc. So this angle has to be congruent to this angle. So the only thing we can do currently is set the two equations equal to each other. Now we're just going to solve. So I'm going to add 2x to both sides. So we've got 4x plus 3 equals 75. I'll subtract 3 from both sides. 4x equals 72. I'll divide both sides by 4, and I'm going to get x equals 18. Once I know what x equals, I just got to plug it back in. So the measure of angle EDF is going to be equal to 2 times 18 plus 3, which gives me 39 degrees. Theorem 1212. The measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. So it's just like the inscribed angles for the most part, except this isn't technically called an inscribed angle. But if your vertex of your angle lays on the circle, then it's going to be half the arc it cuts. So here, SR is tangent to circle Q. If the measure of arc P, MQ, so you go P, M, and then Q this way, you follow the letters like as you go around the circle, is 212, so this is 212. What is the measure of angle PQR? So PQR is this angle here, so we're looking for this. If this arc here is 212, the remaining piece of the circle has to be 148 to make 360. So that means that this angle cuts an arc that is 148. Well, to find the measure of the angle, or in this case, the measure of angle PQR, we're just going to take half of the arc it cuts. So half of 148. So that means the measure of angle PQR is equal to 74. If RT is tangent to circle S, and the measure of SVU is 138, what is the measure of TSU, angle TSU? So we're looking for this angle here, which means we got to figure out the remaining part of this arc. Well, 360 minus 138 gives you 222. So that angle there, or the measure of angle TSU, is equal to 1/2 of 222, which means that this angle equals 111 degrees. And then KJ is tangent to circle O. What are the values of X and Y? So angle X here, or angle X is here, angle Y is here. All right, well, let's see what we can figure out. Well, what we see first is angle X cuts this arc here, which is also cut by this central angle here as well, cuts the same arc. So that means X also has to be 35 degrees, because two angles that cut the same arc and essentially have the same relationship are going to be equal. So X is 35. The next thing we have to look at is how do we find the measure of Y? Well, if we go back to what we have here, if X is 35 degrees, then this arc here is 70. Well, put it together with this arc, you've got a semicircle, and the semicircle is 180, so this arc here must just be 110. And if we look carefully here, angle Y cuts the arc that is 110. So to find the measure of angle Y, we're going to take 1/2 of 110, which in this case gives us 55 degrees. So X is 35, Y is 55.